All right, guys, good afternoon. These are your notes for 10-1, scatter plots and trend lines. Today we're going to be talking about correlation and causation. So we'll start with the correlation part. Correlation is a way to describe the relationship between two sets of data. The first one we have is a positive correlation. With data, it's as one set increases, the other set increases. An example, real world example, would be something like miles driven, or time driven and miles away from home. Okay, the longer you drive, the further away you get. They both increase. On a graph, it goes up from left to right. And it is a scatter plot, so it's not a specific set of lines, it's many dots. But you can see this form kind of a tight grouping. So we have a correlation coefficient. It's represented by R, and we would call this a positive 1. 1 is as strong as a correlation can be. They are also all listed in this box down here. The next kind is a negative correlation. With the data, it's as one set increases, the other set decreases. So another real life situation would be miles driven and gas remaining. The miles driven go up and your gas goes down. On a graph, the graph goes down from left to right. Okay, and this is a correlation of -1. They form a tight line going down. No correlation is there's no relationship between the sets. So that could be miles driven and age of the driver. They have absolutely nothing to do with each other. So this correlation coefficient is 0, and the graph has no pattern. These two down here at the bottom, they're a little rough to see, I know, but this, you can tell there's a positive trend to it, but the dots aren't quite as tight around a line. So we would give this a correlation coefficient of positive 0.5. And in the other, you can see that the data's trending down. But again, they're not in a super tight line. So we would give that a correlation of -0.5. Okay. We're going to look at 1, 2, and 3. Number 1 is the trend is obviously up, but they're not in a super tight line. This would be, I would say, R equals positive 0.5. And that's only because they gave me the choices of -1, -0.5, 0.5, or 1. Realistically, I would probably, if they just said rate it, I would probably say that's a 0.8 because it's pretty close to a tight line. We just have a couple that are outside. Number 2 is obviously no correlation, so the correlation coefficient is 0. And on number 3, they're trending down, pretty tight line. I don't have anything far outside, so this is a correlation coefficient of -1. Okay. All right. I am sorry. Let me get situated here. We have correlation and causation. Okay, this is going to come out of your book. It's on page 357. It's number 9. Okay, and it's kind of long. It says HDL cholesterol is considered the good cholesterol as it removes harmful bad cholesterol from where it doesn't belong. A group of researchers are studying the connection between the number of minutes of exercise a person performs weekly and the person's HDL cholesterol count. The researchers surveyed the amount of physical activity each person did each week for 10 weeks and collected a blood sample from 67 adults. After analyzing the data, the researchers found that the people who exercised more per week had higher HDL cholesterol counts. Identify the variables in the situation and determine whether it describes a positive or negative correlation. Then explain whether the correlation is a result of causation. So causation, it means the change in one variable directly results from the changing in the other variable. So the two variables can have a relation. They can have a correlation, but they don't necessarily have to cause each other. But if you can determine that one causes the change in the other, then it's also causation. Okay, so the first thing they asked us to identify were the variables. Okay, well, the two things that they were studying were HDL cholesterol and the amount of exercise the adults were doing. The next thing it wanted to know was, what's the correlation? Well, they said they found that the more exercise they did, the more good cholesterol they had. So they're both positives, or they're both increasing, sorry. So that makes that a positive correlation. And the last thing they wanted to know is it causation? And we could very well say that causation is possible, or yes, because increased exercise could cause HDL to increase. Okay, an example of something that would have a positive correlation but no causation would be like up at Mount Charleston when it snows. The amount of, like, let's say broken bones goes up. Okay, is there a correlation there? Absolutely. The more it snows, the more broken bones we're going to have because people are skiing. However, did the snow cause the broken bones? It did not. Falling caused broken bones. So that would be where there is a correlation but no causation. Okay, your homework for tonight is 10.1, page 358 to 361, problems 2, 4, 14 to 18 even, and 22. Okay, I hope you all have a great weekend.